convert measurement units. Okay, we're going to scan the lesson. We're going to list 2 headings that we would use to make an outline of the lesson. Okay, so the 2 headings is converting larger units to smaller units and converting smaller units to larger units. All right, the table shows the approximate weight in tons of several large land animals. 1 ton is equivalent to 2,000 pounds. That is your ratio that you're going to use for conversion, okay? It says complete the ratio table. So here it says that the first couple are done for us. If we have a 1 ton animal, that animal weighs 2,000 pounds. If we have a 4 ton animal, that weighs 8,000 pounds. If we have a 5 ton animal, weighs 10,000. Very good. 10,000 pounds. And if we have an 8 ton animal, 16,000 pounds. Very good. So here we're going to take that data and we're going to put it on the coordinate grid. Okay. So first we want the label. So which one goes where? Tons goes on the x-axis, right? So here's tons. And pounds goes on the y-axis. Very good. So pounds goes on the y-axis. So now we're going to plot the points and then connect the points. So we plotted the points and then we connected the graph, the points. So now it says, after we connect the points, describe the graph. What does it look like? A straight line. Very good. So the first thing we're going to do is we're going to convert larger units to smaller units. Okay? Here it says each relationship in the table can be written as a ratio. For example, you know that 1 yard is equal to 3 feet. You can use that ratio, 3 feet to 1 yard, to convert from yards to feet. This is your conversion factor. 3 feet to 1 yard is your conversion factor. Okay? Here, in the textbook, here we have some customary conversions that you should know. Okay? A unit ratio is one in which the denominator is 1 unit. So, let's make sure you write that down. A unit ratio is one in which the denominator is 1 unit. Dimensional analysis is the process of including the units of measure as factors when you compute. All right, so what are we going to use this for? And how are we going to use this? Well, the unit ratio, 3 feet to 1 yard, if you think about that, that is equal to 1. Okay? That is equal to 1. The reason that is equal to 1 is that they both are equal to the same size. The same size, right? So, for example, here I have a yardstick, right? I have a yardstick. This is 1 yard, right? Yeah. There are 3 feet in 1 yard, right? So, 3 feet over 1 yard. Let me ask you this. What's 2 over 2? 1. What's 8 over 8? 1. What's 17 over 17? 1. What's 85 over 85? 1. What's stick over stick? 1. If you have the same thing in the numerator as you do in the denominator, it's equal to 1. Okay? So, if I'm multiplying by 3 feet over 1 yard, which is equal to 1, if I'm multiplying times 1, does it change anything?
No.
No, it just makes it look different. Right? Is everybody clear with that?
Yeah.
All right. So let's take a look at this first example. So here we want to convert 20 feet to inches. Now, since we have 1 foot is equal to 12 inches, the unit ratio is 12 inches to 1 foot. Okay, that's what we're going to use for conversion. I like to do this a little bit differently. It just looks a little different. It's a little more organized, I think. So let's convert using my way of doing dimensional analysis. Okay? So we're going to start with 20 feet. And I do want you to write this in your scribe. Okay? So we're going to start with 20 feet. And then we're going to make a table. We're going to multiply 20 feet times 1 in this format. Okay? In a ratio format. So, if I wanted to place my ratio into the table there, where will I put feet if I want it to cancel? Remember that in order to simplify, you have to have 1 on the top and 1 on the bottom. So, if I want to cancel out feet, where will I put feet? Right here, feet is in the what? In the top, in the numerator. So where will feet need to be in order to cancel out? In the bottom, in the denominator. Is everybody clear with that? So, we will write 12 inches is equal to 1 foot. Now you can see that feet in the top, feet in the bottom, cancel out. What unit am I left with? Inches. And that is the importance of dimensional analysis. You got it? So now this becomes a multiplication problem. This becomes a multiplication problem. And see, it's just like multiplying fractions. You just multiply straight across. So we end up with 20 times 12, 240 inches over, well, this could be 1 down here, 1 times 1, which is 1, which is just 240 inches. Is everybody clear? Yeah. All right, so let's do letter B together. So we're converting 3/4 tons, 3/4 tons, and we're converting that to pounds. Okay? We're converting that to pounds. Now, what is the conversion factor? 1 ton is equal to 2,000 pounds. We just had that in the example, right? All right. Where will I put tons and pounds so that tons will cancel? Very good. Tons will go on the bottom because in the original problem, tons is in the top, right? So we've got 1 ton is equal to 2,000 pounds. And then you'll see that tons and tons will cancel. And what units am I left with? Pounds. Is that what we're looking for? Yeah. So now this just becomes a multiplication problem. Okay? And then we're just going to multiply straight across. So here it's going to be 3/4 times 2,000. Does everybody see that? So 3/4 times 2,000. I'm going to go ahead and put that over 1. Can I simplify before I multiply? Yeah. So 4 divided by 4, 1. 2,000 divided by 4, 500. And when we multiply straight across, 3 times 500,
1,500.
very good. Over 1 times 1, 1. And what are my units? Pounds. Whoops. Pounds. All right, Marco mixes 1/4 cup of fertilizer with soil before planting each bulb. How many fluid ounces of fertilizer does he use per bulb? So here, we're converting 1 cup to fluid ounces. Did everyone see that? Okay. So we have to know the conversion factor. We have to know the conversion factor, and they gave it to us right here. 1 cup is equal to 8 fluid ounces. Okay? So when we have 1/4 cup what am I going to put so that cups will cancel? Where am I going to put it? Cups go where? On the bottom. Very good. So 1 cup here, and then 8 fluid ounces in the numerator. Is everyone with me? All right. So now this just becomes multiplication. And what are we multiplying?
1/4
Times 8 over 1. And my units are going to be fluid ounces. So let's put that over 1. And of course, before we multiply, we can simplify. So 4 divided by 4 is 1. 8 divided by 4 is 2. And when we multiply straight across, we end up with 2 over 1, which is just 2 fluid ounces. All right, the next example is convert smaller units to larger units. Okay. Now here, we just have to remember that 1 yard over 3 feet is the same thing as 3 feet over 1 yard. Those are both equivalent to 1. Okay? So it doesn't matter which one goes on top, which one goes on the bottom. When we multiply, it's still just multiplying times 1. All right. So here we want to convert 15 quarts to gallons. So we know that 1 gallon is equal to 4 quarts. So we want to convert 15 quarts. So that's going to be 15 quarts. And we want to change that to gallons. So here, quarts will go in the denominator. So that's going to be 4 quarts down below. And that's equal to 1 gallon in the numerator. So you can see that quarts and quarts will cancel, and all I'm left with is gallons. And then, of course, this becomes a multiplication problem, and we just multiply straight across. So when we multiply straight across, that's going to give us 15 gallons over 4. So now we just need to change the 15 fourths. We just need to divide that to simplify it out. So when we do that division, you'll see that your final answer is going to be 3.75 gallons. So let's take 3 cups and convert to pints. So the conversion, cups to pints, let's see, we've got 1 pint is equal to 2 cups. So 1 pint is equal to 2 cups. Right? And we're starting with a 3 cups, and we're going to convert that to pints. So, because I have cups in the numerator, I want cups to be in the denominator when I put in my table. So we've got 2 cups in the denominator, 1 pint in the numerator, and now you can see cups and cups will cancel, and we're left with pint. And then this becomes a multiplication problem. So when we multiply straight across, we're going to end up with 3 over 2 pints. And then we're going to do that division. So our final answer is going to be 1 5/10 pints. Alright, for the last example, it says, Rumika needs 4.5 feet of fabric to make a costume for a play. How many yards of fabric does she need? So here, we're converting feet to yards. So we know that 1 yard is equal to 3 feet. Okay? And we are starting with 4.5 feet of fabric. 4.5 feet of fabric. And we're going to convert that to yards. So we're going to put 3 feet in the denominator and 1 yard in the numerator. So here again you can see that feet and feet will cancel, and yards is what we're left with. So when we multiply straight across, we're going to have 4.5 over 3 yards. So this tells you what you're going to divide. And I'm going to go ahead and rewrite this as 4.5 divided by 3. Now, we just we're dividing a fraction, a mixed number, by a whole number. So, we're going to change the mixed number to an improper fraction, so that's going to be 9/2. The division becomes multiplication, and the second fraction becomes the reciprocal. So we're going to multiply times 1/3, which is what they have right here. This, the way I've done it with the table and the dimensional analysis there, it tells you why you're doing that. Okay? So now, we're going to simplify before we multiply. And now we can multiply straight across. And our final answer is 3 over 2, which is equal to, and this is going to be yards. And when you do your division, it equals to 1.5 yards of material.